Next, let's do an application problem, page 570, number 48, distance to the moon. We're going to use the law of sines. So two people, Tom and Alice, measure the angle of elevation to the moon from their point of view. They also know how far apart they are, 300 kilometers. So from this information, apparently we're going to be able to figure out how far it is to the moon. So you can measure an angle, you just make a sight the moon up there, and then you can measure the angle of sight. Just a simple thing. You don't have to go all the way to the moon and measure how far away it is. To be fair, in order to make a good estimate, you have to measure these angles pretty accurately. Look, they're 300 kilometers apart, and the angle differences here it's not a lot, right? So this is going to be an angle-side angle problem. Notice for this angle here, you can't take this 49.9312. Instead, you have to get this interior angle, which is 180 minus that. Okay, so labeling my triangle, I'll call this vertex A. I'll call this one vertex B, so this one has to be C. And so little c is going to be 300. Little c is 300 kilometers. And the way I got B, right, I didn't use the 49.9312. Instead, I took 180 minus this, and that gave me this number right here. Remember that the three angles add up to 180. We know A and B, so I can use that to figure out angle C up here. Well, it turns out that C is 0.0338 degrees, and that's a small angle. It turns out it's about equal to 2 minutes. Remember, a minute is a 60th of a degree. We don't have to worry about that conversion, but the point is, this is a darn small angle. Okay, so I take the sine of this angle here, C, and I divide it by 300 kilometers. I'm going to get this small number here, 1.9664 times 10 to the minus 6. Next, let's bring in the side A. Side A is opposite angle A. Now I can figure out little a from this equation because I know big A up here. To figure out little a, what I have to do is take sine of big A, there's big A, and divide it by this number. That gives me this value for little a, 388,980 kilometers. So that's pretty close to this answer here, of course. We could also figure out this side over here, little b. By the law of sines, this number here, which came from C, would be the sine of big B over little b. And so I can do the same thing that I did to get little a, except I would use the sine of b instead. When I do that, I get this value for b, 389,000 miles. So, roughly speaking, the moon is going to be 389,000 kilometers away. It tells us it's not 10 miles away, it's not 100 miles away, it's not 1,000 miles away, it's like 390,000 miles away. Still, doesn't it always amaze you how big and close the moon looks when you have this optical illusion of the harvest moon?